Okay, welcome. HX solution, a sum engine series, lesson 5, method of difference. So method of difference is a technique that is used to find sum of a finite series, whereby the series is a telescoping series, right? So a telescoping series is a series whereby the terms are cancelling each other as we move from term number 1 up to the end the term, and we'll be left with a few terms. So that's a telescoping series, right? So let's say we have this function here. We have a summation of r equals to 1 up to n of a generator here, and if this generator can be expressed as a function of two terms here, so we can use method of what, of difference here, right? So let's look into this one, right? So when r equals to 1 here, we are going to have f of 1 minus f of 2 if we put 1 here and we put 1 here. Alright, when r equals to 2, we are going to have f of 2 minus f of 3. Then when r equals to 3, we are going to have f of 3 minus f of 4 here. Right, so if you start the pattern here, you're going to see that minus f of 2 and 2 will cancel out here. Then minus f of 3 and 3 will also cancel out here. So this term will cancel with this one, and this one will also cancel with this one. And minus f of 4 will automatically cancel with the term at r equals to 4, right? Then this will continue up to the end the term. Alright, so before we reach the end the term, we have the previous term from the end the term. So that term will be when r equals to n minus 1. So when r equals to n minus 1, you can have f of n minus 1 minus f of n here. Then when r equals to n, we are going to have f of n minus f of n plus 1, so which is our last term here. So you can see that here the terms are also cancelling. This one minus f of n minus f of n minus 1 will cancel with the previous one here, and this one minus f of n, and this one also cancel here. Then minus f of n plus 1 will not cancel, so we automatically are going to be left with this term f of 1 and minus f of n plus 1. So therefore summation from r equals to 1 up to n of this function, which has been expressed as a function of two terms, is equals to f of 1 plus f of n plus 1. Right, so let's look into the example here. Alright, before we go to the example, we have tips that you need to understand. So how to use the method of difference. So it's either we are using an identity which is given, or you express UR in partial fractions. Alright, so let's go here to the example that we have. Alright, given that this function is equal to this function, right? Then find a summation of r equals to 1 up to n of 1 over r plus 1, r plus 2. So you can see this is a single generator. It's a function which is a single term here. So from the given part, you can see that this term can be expressed as a difference of two terms here. So which means summation of this singular term is equals to summation of these two terms which are separated together. Alright, so now we can find summation of r equals to 1 up to n using this term. So when r equals to 1, we are going to have 2 over 3 minus 1 over 2. Then when r equals to 2, we are going to have 3 over 4 minus 2 over 3. Then when r equals to 3, we are going to have 4 over 5 minus 3 over 4. Right, so if you start the pattern here, you're going to see that 2 over 3 minus 2 over 3 is 0. Then 3 over 4 minus 3 over 4 is also 0. So the terms are cancelling like this. This one will cancel with this one, and this one also cancel with this one. Then 4 over 5 automatically will cancel with the term with r equals to 4. Right, so this will continue up to the end of the term. Alright, but before we arrive at the end of the term, we have the previous term. We need to start the pattern here. So we can start maybe at r equals to n minus 2, but in this case we can start at r equals to n minus 1. Alright, so when r equals to n minus 1, you are going to see that we are going to have n over n plus 1 minus n minus 1 over n here. Then when r equals to n, we are going to have n plus 1 over n plus 2 minus n over n plus 1. So you can see the pattern is still the same. This term here will cancel with the previous term, and this one will cancel with this one. So now what are the terms are left? You can see we have this term which is left and also this term which is left here. So what does it mean? It means summation of this function from r equals to 1 up to n is equals to minus half plus n plus 1 over n plus 2. Right, so that's how you find the sum here. Right, so let's go to the next example here. All right, so our next example show that this function r plus 1 over r plus 2 factorial is equals to 1 over r plus 1 factorial minus 1 over r plus 2 factorial. Then hence find summation of r equals to 1 up to n of 2 times r plus 1 close brackets over r plus 2 factorial. Right, so the first thing we need to show this one, then we'll use the result that we have here to find the summation here. Alright, so let's go on the showing part here. Right, so this is the function that we have equals to this function. So we need to show this function on the left hand side is equals to this function on the right hand side. So we are going to take the right hand side here, this one. Right, so we have 1 over r plus 1 factorial minus 1 over r plus 2 factorial. So we are going to put the common denominator here. So our common denominator is r plus 2 factorial, then r plus 1 factorial. Right, so then we put our common denominator here. Alright, so this highlighted part which is in blue here, that's the one that we want to break here so that we can have a common factor here, then we can factor out here. Right, so you can see that r plus 2 factorial is equals to r plus 2 open brackets r plus 1 factorial. Right, so let's look into this with how does it goes about here. So 5 factorial is equals to 5 times 4 factorial. So that's the similar thing here. R plus 2 factorial, we just subtract 1 here, so it becomes r plus 1. So we are going to have r plus 2 times r plus 1 factorial. Right, then minus r plus 1 factorial all over r plus 2 factorial, then r plus 1 factorial. Right, so now we can factor out r plus 1 factorial here. So we factor out r plus 1 factorial, then we are left with r plus 2 minus 1 close brackets all over r plus 2 factorial, then r plus 1 factorial. So r plus 1 factorial will cancel with r plus 1 factorial here. Then we are left with r plus 1 all over r plus 2 factorial. Alright, so now we have shown that the left hand side is equal to the right hand side. So now we are going to the hence part here where we need to find the summation of this function from r equals to 1 up to n. Right, so going back to the identity here, so we just take our identity as it is. So summation of r equals to 1 up to n of the left hand side of the identity is equals to summation of r equals to 1 up to n of the right hand side. Right, but if you look closely, there is this 2 here, so which means I can multiply with the 2 on this side and I also multiply 2 on this side. So let's multiply with 2 here. It's just a constant, so we multiply with 2. So we are going to have summation of r equals to 1 up to n, then we multiply with 2 throughout. Right, so what actually are we going to do? We are going to take this side and apply the method of difference, because this function here has been expressed as a function of 2 terms here. Right, so let's now go here. Right, so when r equals to 1, we are going to have 2 over 2 factorial minus 2 over 3 factorial. Then when r equals to 2, we have 2 over 3 factorial minus 2 over 4 factorial. Then when r equals to 3, we have 2 over 4 factorial minus 2 over 5 factorial. Right, so now you can see there's a pattern which is forming here. Minus 2 over 3 factorial plus 2 over 3 factorial will automatically give us a 0. Then minus 2 over 4 factorial plus 2 over 4 factorial will automatically give us a 0 here. So which means the terms are cancelling like this, and this one will also cancel with this one. Right, then when r equals to 4 here, automatically minus 2 over 5 factorial will cancel with the term at r equals to 4. So this pattern will continue up to the end of the term. Right, so we can now go for r equals to n minus 1 before we arrive at the final term when r equals to n. So when r equals to n minus 1, you see that we're going to have 2 over n factorial minus 2 over n plus 1 factorial. So automatically, there's a term here that is going to cancel with the previous term when r equals to n minus 2 here. So let's go for r equals to n here. So for r equals to n, we are going to have 2 over n plus 1 factorial minus 2 over n plus 2 factorial. Right, so the pattern is just continue like always. So this one will cancel with the previous term here, and this one here will cancel with this one. So we'll cancel here. So now what are we left with? You can see that we have arrived at the final term, which is r equals to n. So this term is now left, and this one is now also left. So which actually means summation of this function here is equals to 2 over 2 factorial minus 2 over n plus 2 factorial. Right. So thank you for watching the videos. Please subscribe and comment. See you in the next lesson.